Hello and welcome for the sixth and optional final tutorial in this series on quadratic functions. This is sort of for the hardcore mathematicians among you who are just curious, where does that quadratic formula come from? And I'm going to derive it for you by completing the square on the general form of the quadratic function. This is most certainly not in any syllabus, I believe, at this level of maths, National 5, O-level, kind of 16-year-old kind of level in high school. But it's something that, is kind of interesting, and it demystifies that quadratic formula. I think you'll be able to follow along. Don't worry about trying to reproduce this unless you really want to. The techniques we'll be using are something that are asked about in the next higher level of maths here in Scotland. Right, so quadratic functions continued, and in fact the final optional tutorial. So we have the general form of the quadratic function is y equals ax squared plus bx plus c, and we also know that there is something called the quadratic formula, which tells you the value of the roots, and that quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And the question is, how do you get from there to there? And let's see. What we want to do is complete the square on this general quadratic function. And we're just going to follow the methods, or the steps rather, that I have taught in previous tutorials. The one complication that we haven't really come across heretofore is that all the examples that I did when I completed the square, a was 1, because at this level of maths in Scotland they don't want you to have to complete the square if a is different to 1. But here we have just a general number called a sitting there, and it just introduces an extra step, but as you'll see, it's nothing particularly difficult. So first thing we do with completing the square is ignore this poor last term, just gets ignored, okay? And we're just interested in ax squared plus bx. Now, what we have to do, this extra little step, is we need to get rid of that a. And so what we're going to do is just factorize. So we're just going to write a brackets x squared plus, now I want to get bx, so I have to write b divided by a times x. So if I multiply this bracket by a, I get back ax squared, and then here I get back bx. And it's this bit in here now that where all the action is. Okay, once we've figured out this bit, we're just going to multiply by a, we'll add back the c, and we're done. So the action then now starts with looking at x squared plus b over a times x. And we know what to do, because we say, right, we want to write this as x plus something squared, and we know there's going to be a correction as well. So we're going to get minus something as well from the correction. And what do we put in here? We put in half the value, right? So the object here is b over a. We know we have to put in half of that. And let's just see whether this makes sense. Let's just check what we're doing is sensible. What is this thing, x plus b over 2a squared? It's this times itself. X times x is x squared. I have x times b over 2a. I have another x times b over 2a. And I have, this rather scary thing, b over 2a all squared. These two add up to xb over a, or b over a times x. So this is all looking very positive. These terms give me what I want. This is the overshoot. That's what we have to subtract off. Okay. I'm actually going to choose to write it, I think, am I? Yes, I'm going to write it as b squared over 4a squared. So I'm just writing it as b times b on the top and 2a times 2a on the bottom, namely 4a squared. So you wouldn't really have to do this extra step. I'm just showing it to you for clarity so you can sort of see why things are working. So that's actually, to be honest, that's the hard work done. The rest of it's a piece of cake. We've completed the square on these two terms. We now need to multiply through by a. So ax squared plus bx is a times this thing. So it's going to be a times this minus a times this. If I multiply this by a, I'll just have an a on top and an a squared on the bottom. So I can cancel those a's and I'll just be left with 1a on the bottom. You know, I'm actually going to, no, I'll just write that. I was going to do an extra step, but I think you can see that if I multiply through by a, I just can cancel that a with 1 on the bottom. I'll be left with b squared over 4a. That's very good. So if I just shift the paper up a wee bit there, I can just fit in the last line here. So we're actually done here. Look, we have our quadratic function. We've completed the square because we have ax squared plus bx, which are these two terms. And then we just bring back that ne'er-do-well that just hangs around, the loiterer. We just bring that back. And that is the same function. Now I will admit to you at first glance this does not look as nice as that, but actually this is transparent and that is opaque. Why is this transparent? Because look, it's just a times something squared plus a constant. Okay, so we can read off the turning point of the quadratic function straight away, because that will occur on this axis of symmetry when this vanishes. So the axis of symmetry will be when this thing vanishes, and that's when x equals negative b over 2a. But what we're after are the roots. The roots, okay, so the roots are those values of x when y equals 0. Okay, I hope I've got enough space to do this. Let me just give myself a bit more territory here. Y equals 0, so I want to set y equal to 0. So I'm going to have then a times x plus b over 2a all squared minus b squared over 4a plus c is equal to 0. This is why this tutorial is optional, because this probably looks really ugly and horrible, but you know, it's just a bit of algebra. The ideas are very simple. They're things that you've already seen in previous tutorials. It's just some algebra. This is why it's so good to treat algebra and equation rearranging like a potter treats clay. It's just stuff that you can get your hands on and mess around with. As long as you make correct steps, nothing bad can happen, you know. So the roots will be the values of x for which y is 0. So here's the quadratic function, and we're setting it equal to 0. So we just have to solve this equation for x, and that's actually not too bad, because x only appears once inside this square. So let's get this stuff on the right hand side to start with. So we have a into x plus b over 2a all squared equals, let me move this term over, So I get b squared over 4a, and let me turn this term, move this term over, I get minus c. And what I would like to do is express this as one fraction. So I'm going to multiply this upstairs and take everything over 4a. It's a bit like subtracting fractions. If I think of this as c over 1, I want to add these two fractions together and put them over a common denominator. So this is going to go up there, and it's all over 4a. So I get b squared minus 4ac all divided by 4a. Does that look rather familiar? All of a sudden it's starting to come into shape, isn't it? Let me divide by a. Get rid of that. So I then have x plus b over 2a all squared equals this divided by a. That's going to come downstairs. So I have b squared minus 4ac. This a comes downstairs, and I have 4a squared. Now, to get at x, I have to take the square root, because that will make the left-hand side very simple. So by taking the square root now, I just have x plus b over 2a equals the square root of all this stuff. Okay, the square root of b squared minus 4ac divided by 4a squared. And now we can remember our kind of surd training. You can see why these different things that we've learned in different tutorials are useful, because they come in at odd moments. Here we want to be comfortable with surds, that I have the square root of a quotient. I can just write that as the square root of the numerator divided by the square root of the denominator. But the square root of 4a squared is just 2a. So I have that x plus b over 2a is the square root of b squared minus 4ac all over 2a. Now, remember in the previous tutorial when we used completing the square, we got the roots from the completed square, and I just pointed out to you that when you take the square root of something and write it in this way, you actually have two values there. So, you know, if this number was, say, 25, then we take the square root, we get plus or minus 5, because negative 5 or plus 5 squared is 25. So we're just being explicit by putting plus or minus here that there are those two different solutions. And so finally I just have to take this term across, and I have x equals minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. And that's that. We've finished. We can take both these terms are over 2a, so we can just write it as one big fraction, but that's the quadratic formula. So, sorry to wax lyrical here, but the completing the square is the prince of quadratic functions, because even the most general case, where there's no numbers, just symbols, it just chews it up and gives you the parabola in the general form from which you can actually find the roots, and it spits out kind of rather disdainfully the quadratic formula, as if that was just a piece of cake. So I hope this is for the kind of hardcore mathematicians among you who just like to see where things come from. I hope this has kind of been a bit fun and helpful. It's well beyond what you'd be expected to do at this level of maths, but there's nothing here conceptually beyond what you know. It's really just a bit of messy algebra, to be honest, and you see that we can indeed derive the quadratic formula. So I hope this mini-series on quadratic functions has been useful. I've really tried to show how everything is connected, that it's really quite a pretty subject, that you can look at things via roots or via completing the square, so on and so forth. And we are coming to the end, actually, of the curriculum of the Scottish National 5, which I'm imagining is quite close to the curricula of similar high school topics, subjects, at this stage. So we have a few more topics to do, which I'm looking forward to covering, and then we will be done. So I look forward to seeing you for the next topic.